Hello everyone, now I'm going to demonstrate how to model this example in ABAQUS. Now let's take a look at the example first. So we have a sandwich structure shown below, and it is composed of three components. So we have a top layer, a core layer, and a bottom layer. So the top layer is tied to the core layer, and the core layer is tied to bottom layer. And for the loading and boundary conditions, so we have a moment of 10 Newton millimeter is applied to the left end. And for the right end, it's completely fixed. So for the top and bottom layers are made of steel with a Young's modulus of 200,000 megapascal and a Poisson's ratio of 0.3. And for the core layer, it is made of a different material with a Young's modulus of 10,000 megapascal and a Poisson's ratio of 0.3. Now let's take a look at the dimensions of top and bottom layer and core layer. So for the top and bottom layer, we have the same dimension. So the length is 64 and the width is 20. The thickness is 2 millimeter. For the core layer, so the length and the width are exactly the same as the top and bottom layer. However, we have some hollow rectangulars in core layer. So since we noticed that the top and bottom layer has the exact dimension, so when we create parts, we don't need to create 3 parts. We just need to create 2 parts. When we create instances for this part, we can just create 2 instances for this part when we assemble them. So now let's get started. So I'm going to create 2 parts first and then assemble them in ABAQUS. So first we are going to go to part module and create a part. So we noticed that this part is a 3-dimensional part. So we are going to create using 3-dimensional modeling space and deformable, because after simulation we are interested in the deformation. And we are going to use a solid extrusion, because we can get this part by extruding this sketch 2 millimeter along the depth direction. So we can use approximate size as 200. Click continue. Now let's click this create length to create a rectangular. So here I'm going to create a random rectangular, and then I'm going to put dimensions on it. So the length is 64. So let's use add dimension and put length to 64 and hit enter. So, and for the width, it's 20. So let's put 20 here and hit enter. Now we hit the middlemost button and we are done with part 1. So, and it's 2 millimeter. Click OK. Now we are ready with part 1. So let's change its name to top and bottom layer. Click OK. So next I'm going to create this part. So create another part. Let's call it core layer. So we are going to use the same setting, 3D deformable solid extrusion, and click continue. So I'm going to create another random rectangular and then put exact dimension on it. So this is 64. Let's hit enter. and this is 20, right? This is 20. So let's hit enter. Now we have the this part, and next we are going to create this hollow rectangular. So let's create a random rectangular here, and then so let's find the dimensions for this hollow rectangular. So with respect to this edge, this distance is 4. With respect to this edge, this distance is equal to 20 minus 10 divided by 2. This is equal to 5. So let's put this distance is 4, right? It's 4. So it's already 4. Let's just hit enter. And for this distance, it's 5. So it's already 5. Let's hit enter. And then we are going to put the dimension for this hollow rectangular. So for this hollow rectangular, the length is 10. The height is 8. So the length is 10. It's already 10. So let's put hit enter. And the height is 8. Let's put 8. So then we are going to create this the same hollow rectangular 4 times. So one way to do this is create a random geometry and then create put exact dimensions one by one. However, another thing we can do this is to use this option, which is called a linear pattern, because we can create a linear pattern along this direction, right? So let's create a linear pattern for this structure. So we create click linear pattern, and then we need to select this hollow rectangular and then click down. So here you can see for the direction 1, which is the horizontal direction. So for this direction, we just need 1, right? And for this direction, so we need 1, 2, 3, 4, 5. So we need 5. So let's put 5. And another parameter we need to define is the distance between the center of this hollow rectangular to the next hollow rectangular. So we know that this distance is 4. So let's check this distance to this distance. So half of this is 4, right? Because the height is 8. And this distance is equal to this one. It's 4. So the center line of the first hollow rectangular to the center line of the second hollow rectangular is 12. So we can just put 12 here. Then we can hit OK. Now you can see we have this hollow rectangular. We created another 5 hollow rectangular using this option. Now we are done with the second part. Let's click down. So for this part, it's 10 millimeter. So let's put 10 here and click OK. You can see we have this beautiful structure ready. So now we are done with 2 parts. So I'm going to assemble these 2 parts first. Or we can just mesh them first, it doesn't matter. So let's follow the same order that what we did previously. So let's create 2 materials first. So for the bottom top layer, so we are going to create an elastic material with So for the top and bottom layer, the Young's modulus is 200,000. So it's 2 to the 2 times 10 to the power of fifth and 0.3. This is the first material. Click OK. And then let's create another material which is called a co-layer. So material, okay. And then let's create another elastic property for this material. And this time the Young's modulus is 10,000 and the Poisson's ratio is 0.3. So it's 10,000 and it's 0.3. Click OK. Now we have two materials. So we are going to create two cross section. So for the section 1, it's called bottom and top section. So it's going to be homogeneous solid. Click continue. For the material, it's a bottom and top layer. And click OK. For the second cross section, we are going to create a section for core layer. So let's call it core layer section and solid homogeneous. This time we are going to use the core layer material property. Click OK. Then, so we are going to assign material properties for these two parts. So for this part, it's called a core layer, right? So we are going to assign the core layer to this and click down. So section, core layer section, click OK. And then we need to switch to another part. So we can do it here. Then let's assign another section to this top and bottom layer. Click this one and down. So we are going to use bottom and top section. Click OK. Right. Now we are done with the material properties. Next step, we can go to mesh. So let's mesh this part first. So we are going to use says global seeds. So let's put 5 and apply, see if it's good enough. It's a little bit coarse, so let's put 2.5 and apply. Now it's it looks better. So let's use 2, apply, OK. Then we use mesh part, yes. And now we have meshed this part successfully. Then we are going to use we are going to assign elements tab to this part. We are going to use 3D stress. So I'm going to use for integration. So I'm going to untick reduce integration and click OK. Now let's switch to the core layer and mesh it. So I'm going to use the exact global size as the bottom and the top layer for this one. So apply and click OK. And then we mesh this part, yes. So we can see we have some distortion. If you want to improve this, you can go to hex and use this option to minimize the distortion. Click OK and delete it, and then mesh it again. So you can see it's now it's much better. Now let's let's assign elements tab for this part. So I'm going to use for integration, 3D stress, and click OK. Now we have two meshed parts. So next we are going to assemble it. So this time we are going to assemble these two parts in this sandwich structure. So first we are going to create an instance for the top and bottom layer. So let's click OK. Then we need to bring in another part So this time we can create this part called, we can create another instance for core layer. And so click OK. So you can see here, they are overlap with each other, right? So if you don't want, if you want to separate them a little bit, you can use, you can just delete this one and use, when you create an instance for your core layer, you can just check auto offset from other instances. Click OK. Now you can see it's separated from the first instance that we created. Now we are going to align this surface to this surface, right? So how can we do that? So we need to use this option, this function, which is called create constraint. So parallel face. So now we are going to use the face to face. So we right click this button and hold it, and then we can move it to the face to face option and then release it. Now this time it's this option switched to create constraint face to face. Let's click this one, and then we are going to select two faces that need to be aligned to each other. So we first select this one and this one. Then you can see we have two arrows. It means that these two arrows will be overlapped to each other. Then we just click OK. So if you click flip, so one of the arrows will flip to the other side. So it means if you use this option, so this part will rotate 180 degree when they align this face to this face. So let's flip it again and click OK. So for the distance from the fixed plane along its normal. So because we want this face to be aligned to this face exactly, so we put 0, 0 and hit enter. You can see now these two faces are aligned to each other. Now we can just create another face-to-face constraint. This time we are going to constrain this face to overlap with this face. So select this one. So now you can see this time the arrow is different. So let's flip it. Now click OK and hit enter. So you can see now they are in the same plane. So this face and this face are in the same plane. Now we need to align this face with this face. So we select this face and we select this face. So you can see this time the arrow is exactly in the same direction. So we don't need to flip it and just click OK and hit enter. Now you can see we have successfully assembled the bottom layer and the core layer. Next, I'm going to create another instance for the bottom and top layer, so that that instance can be used for the top layer of our sandwich structure. So let's click create instance. This time I'm going to create an instance for top and bottom layer again. So I'm going to use this option. So click OK. Then you can see that this part is separated from our assembled structure. So now we are going to use the face-to-face constraint 3 times to align the face along the X, Y, and Z direction. Now let's do this. So click face-to-face constraint, click this face and this face. And then the normal direction is the same. So click OK. And the distance is 0, hit enter. Next, we are going to create a face to face along Z direction. So we click this button so that we can rotate this structure. And then once we are done with rotation, we can hit the middle mouse button and select this face. And then we select rotation again. And once we are done, we hit middle mouse button and then select this face. Since the direction, normal direction is different, so we can flip. So now they are aligned with each other. Click OK. And the distance is equal to 0. So click hit enter. Now we are going to align the X direction. So we are going to select this option and select this face and this face. The normal direction is the same. Click OK. And the offset is 0, 0. Let's hit enter. Now you can see the structure, our sandwich structure has been assembled successfully, right? Next time we are going to, so we are going to create a step. So we are going to use static analysis. So let's, and this step is called, let's call it sandwich structure. And let's turn nonlinear geometry on. And the increment size doesn't matter. So let's put it 0.1. And here, let's click OK. And now we have created a step. So here is our step. Now we are going to create two constraints. So first, we are going to create a constraint to tie the core layer to the top layer. And the second constraint, we are going to create a core layer. We are going to tie core layer to the bottom layer. So this is a tie constraint, and for another constraint, we also need to create a constraint to make a left surface rigid. So now let's first go to interaction module and create a tie for the top layer and the core layer. So in order to create a tie, so we need to create two surfaces, right? So one is master, the other one is the slave. So for convenience, you can create a surface here first. Then, or you can just create a surface during the process of creating interaction. So the advantage of creating surface here is that it's convenient for selection. So I'm going to show you, I'm going to create surfaces here. So you can click create surface. So let's call it top layer surface. And it's from the geometry. It's not from mesh. So let's click continue. And now I'm going to select the bottom surface of this top layer. So, but we can't see it, right? So we need to use the display option. So we can use this is called replace. So we click this one, and then we select this part. Let's select, it's called cell. Let's select this one, see what happens, and done. So we can only see this surface, right? So if you use this option, replace all, and then you can see all of them. So now let's try it again. Replace selected, and we are going to use the cell. So we select this one and click done. Now we can just create a surface. So now we are back to this option, select the regions for surface. So we rotate this and hit the middle mouse button and select this face and click done. Now we created this surface. Now we are going to show all of them and select and isolate core layer to select the top surface of the core layer. Okay, so let's create another surface called top core layer surface. Create a continue, and this time we are going to isolate this, right? So we need this. We need to select this and put it to cell. Select this one, done. And then we are back to the surface selection option. So we select this surface and click done. Now we created another surface. So now let's show all of them. And then we need to create the bottom surface. Let's call it bottom core surface for this surface. Continue. And then we also need to isolate the core layer. Click done. So this time we are going to create this the bottom surface of the core layer. Hit middle mouse button and select this one and click done. So now we have created a bottom core surface. Now let's create the last surface, which is the top surface of the bottom layer. So bottom layer. So click continue. So now we need to show all of them and select replace selected again and select the bottom layer. Click down. So let's rotate this and then hit the middle mouse button, and then we can select this surface. Click down. Now you can visualize all of them. So you can see this is the bottom core surface. This is the top bottom layer surface, and this is the top core layer surface, and this is the top layer surface. So now it would be much easier if we create then it will be very easy for us to create a type constraint. So we go to create a constraint and we create a type. So we are going to have two types. One is the top type. So for the top types, we are going to create. We are going to use two surfaces. So for the master surface, so we need to select the surface that we created earlier. So the master surface is the bottom surface of the top layer. So top layer surface, right? This is this will be our master surface. So for the difference between master surface and sleeve surface, so we usually use the stiffer one as the master surface. So as we can see that for the top layer, the Young's modulus is 200,000. So we use the master surface, top layer surface as a master surface. Continue. And then we need to select a sleeve surface. We are going to use the top surface of the core layer. So it's a top core layer surface. So click continue. And now you can see we have successfully selected them. So if you found that you want to reverse their order, you can just click this. So then you will see that the master surface will switch to this one and the sleeve surface will switch to this one. Let's just switch it back. So, and for this called discretion method, so when you put it to analysis default, it's going to use the surface to surface discretion method. And for the difference between the load to surface and surface to surface discretization, I'm going to introduce more. I'm going to talk more about it in our next class. So for the exclude shell element cyclists, if you are using shell elements, so you can use this option to exclude the cyclists. So for example, when we create the shell elements, this is the shell, right? And we have the cyclists. So if you let this, if you tick this option, then this will be your surface. If you untick this option, then your test surface will be either this surface or this surface. That's the difference. And so for the position tolerance, we can just use the computed default one. So for this option, it's used to judge if the distance between two loads is within this tolerance, then the software will think that these two loads are tied to each other. You can also manually specify this distance, but usually we use the default one. And the next option is called adjust sleeve surface initial position. So if we tick this option, then the software will move the loads on the sleeve surface to the master surface. Yeah, we usually keep this option. And then another option is called tie rotational degree of freedom. So when we use tie, so the 3 transitional degrees of freedom and 3 rotational degrees of freedom will be tied to the master surface. However, the ABAQUS give us the option to untick this. So if you untick this, it means only transitional degrees of freedom of a sleeve surface is attached to the master surface. So let's just keep the default option and click OK. Now let's create another tie constraint between the bottom layer and the core layer. So we click create a constraint, and this time let's call it bottom tie, and click tie and continue. So we click now we need to choose the master surface. We click surface, as we have created the surfaces already, so this window will pop up. So for the master surface, we are going to select the stiffer surface, which is the top surface of the bottom layer. So it's a top bottom layer surface. Click continue. And for the sleeve surface, we are going to use the bottom surface of the core layer. So it's a bottom core layer surface. Click this one and click continue. So we are going to use the default options and click OK. Now you can see we have successfully created 2 constraints. You can check if you have successfully or correctly created the constraints by clicking this. Now you can see the tie constraints are highlighted. Same here. Next, we are going to create a rigid body for the left surface so that we can apply our moment on this surface. So before we create a rigid body, we need to create a reference point first. So let's click this icon, create a reference point. So when we create a reference point, you can always pick points on this. You can pick feature points on your geometry. For example, I can pick this one, and I can pick this one as our reference point. So after you have created your reference point, you can see your reference point in the assemble and feature. Here is your reference point. However, if you created a reference point by picking these feature points, you will not be able to modify it. You can see the selected feature has no modifiable parameter. So this is a limitation. And so I would like to create a reference point by inputting the coordinates. So if we take a look at the dimension of the geometry, we noticed that the length is 64 and the width is 20. So the entire thickness is 2 plus 2 plus 10, so it's 14. So then we can find that if we want to create a reference point at the center of the left surface, so we know that the coordinate of x is equal to 10, and the coordinate of y is 64, and the coordinate of z is equal to 7. Let's hit enter. So you can see we have successfully created a reference point in the center of a left face. If you click this reference point and click edit, you can change the coordinates value. Now let's create a rigid body, and let's call it left rigid face, and let's click rigid body and click continue. So we are going to use the tie, and we are going to select these 3 faces. So in order to select multiple faces, so we have to hold shift and click this one, and this one, and click down. And then we are going to select a reference point that we just created and click OK. Now you can see we have successfully created a rigid body. So your rigid body can be found here. So this is a top test, this is a bottom test, this is your left rigid face. Now we just need to apply boundary conditions. So for boundary conditions, I'm going to apply a encaster on the red surface. So since I tested this case, so I already applied this boundary condition here. So for the left surface, so since I deleted it, so I will get this error. I will get this warning. So now I have to delete this again. So in order to delete this boundary condition, you have to go to the model tree and delete this boundary condition and click delete. So you can't delete this boundary condition within this step. Now we have successfully deleted the boundary condition. So let's create a new one. So for this, we have to delete, I deleted the wrong one. Let's delete both. So now we have created a boundary condition, which is fixed, which is encaster for the right end. So we can call it right end and click continue. So now let's rotate and hit middle mouse button, switch back to the boundary condition panel and hold shift because we are going to select multiple surfaces and hold down. So we are going to completely fix the red surface, click OK. And then we are going to apply a load. So which is the moment. Let's click moment and select this moment and click continue. So we are going to select this reference point and click down. So for the moment, so we are going to apply a moment along X direction. So we are going to apply a moment to bend this structure. So we will have a moment along X direction. So it's 10, right? And 0, 0. Moment is 10. So let's click OK. Now we have successfully applied a loading condition and boundary condition. We just need to create a job and submit the job. Let's call it sandwich structure and click continue and click OK. Now we just need to submit the job. So we can open monitor to check the status of our job. So you can see the analysis input file process has completed successfully. So it means there is no error in the model setting. So now you can see that our job has been completed successfully. Now let's check the results. So results. So here we can see when we click the deformation, we can barely see anything, right? So that's because we applied a very small load, which is 10 Newton per millimeter. So in order to make this small displacement visible, so what we can do is we can change the deformation scale factor. So for the default options, when we turn on the nonlinear geometry, the software would use 1 as the deformation scale factor. Since here we have a very small deformation, let's use 100,000. Let's click OK. Now you can see that the displacement is very obvious, right? And this is our S22. So let's check S11. So which is also very small. So we can also check the displacement U. Let's check U1. So you can see the displacement is continuous, right? That's because we use the tight constraint. So these two surfaces attached to it together is acting like one surface.